Alright, so now let's do the same exercise using recurrent dropout. So I'm gonna take this file that we just used and I'm gonna make a copy. Here we are. And open that file. Basically adding recurrent dropout, we only have to add 2 arguments in the GRU layer. Alright, we will say this here, GRU with recurrent dropout. Alright, and then we're gonna run the code actually just to see if the drive is mounted or not. And we're not gonna run all the code and go through all the epochs. Still waiting. Okay, here we have to get our code as usual. So let us do that. Copy that code and put it in. Alright, now press enter. And then we will break actually the execution of the program here, runtime interrupt execution, because I don't want to go to the epochs processing. So let's go down here and add 2 arguments here at this GRU layer. So here we're gonna add dropout equals to 0.2, and then we're gonna add recurrent dropout equals 0.2 as well. And let's increase the number of epochs to 40. And now let's run the code. Run all. Here we go. Oh, problem here. Invalid syntax. Recurrent dropout. Here, I forgot a comma. Alright, so let's rerun. And now we're in business. Alright, so this will take a while. Alright, while this is running, let's look at stacking. Yeah, so let's go back now here. Again, we take this file, let us duplicate it. It's still running, but that's not an issue. So let's open it. Alright, here we are, and let's at least make sure the drive is mounted. So run before, and here recurrent dropouts, and before that we're gonna put in stacking. Stacking like this. I'll take out the copy and go get my code. Here we are. Then we paste it. All right. This will be done in just a few seconds. Here we are. So what we're gonna do is now go down to the model again. We leave the dropout and recurrent dropout as is, but we're gonna add another recurrent layer. So let's copy this and let's paste it. Here we are. Alright, so the intermediate layer should actually output their results at the end of this layer. So what we need to do is we need to add this argument. Recurrent sequences should be set to true. And now the next layer, we're gonna increase the number of units here. We will keep the dropout, but we use activation equals relu. All right. And the rest I don't really want to touch. But this I can leave out here now. So here we go. And then dense is still 1, and the rest I will not change. So we can run it all now. See, we have a mistake here. It's not recurrent sequences, it's return sequences. So let's get back on track. All right, we're done with our 40 epochs, and let's plot the results. So here the traditional block of code, let me run it. And what do we see? Well, the mean absolute error has barely changed. It went from 0.28, so more to the 0.29 level. We're not really overfitting, yes, although here there is some tendency to overfit. All right, so this is the outcome here, 40 epochs. So we plotted the results immediately, and here you see that the validation loss is actually kept under control. So we definitely fight overfitting in this case. However, when we look at the result, the mean absolute error is still in the area of 0.28. So we've not really improved the performance of the system. We mainly improved overfitting of the system.